So, welcome back to another lecture of our UPSC, which is a part of our nomenclature, which helps us to understand how to name general organic chemistry compound. So, in the last lecture, we learned how to in the last lecture we learned what are word root, prefix, suffix, and in this lecture we're gonna learn how to place them. There are few rules to when it comes to the naming of a compound. There are few rules that we had to follow in order to name them perfectly. So this is the general rule, followed rule, where we first see numbers of carbon with respect to the bonds which is present. If it's pi bond or sigma bond, there is something I will tell you later. Number of substituents, then comes number of substituents. Remember, substituents and functional groups are different. Substituents are the one which are used in place of secondary prefix. Remember it. Substituents are one that are added before the word root. Lowest set of locates. It's a rule I will explain to you later. Locates basically means location and alphabetical order. So without any further ado, let's start. Okay. Wait, let me. So what does it say? It says select the longest IUPAC nomenclature of branched and complex alkanes. So we ain't gonna encounter any pi bond or double pi bond here. The first rule is select the longest carbon chain. It goes back to that number of carbons word root. So see, if we count from here, 1 2 3 4 5 6. Wait, let me change the color, or so 6, we got 6 from here. When we count from here, 1 2 3 4 5 6, it's still 6. But when we count from 1 2 3 4 5 6 7, so considerably this is the longest chain in this compound, so which will give it the highest word root of hept. When chain contains equal length competing for selection, that then the chain is selected which has more number of substituents for branches. So it goes on to the second rule, number of substituents. So if if a compound being read from different endpoints and it contains the same word root, then we will see which has the most number of substituents. Substituents like this thing, it's detached from the main chain. So like if we count from here, 1 2 3 4 5 6 7, we will only get 2. These two substituents will get. But if we count from here, 1 2 3 4 5 6 7, we will get the highest, 7. And then we will also get 3 substituents. See, we are getting 3 substituents, which makes it follow the second rule, number of substituents, which means means in this one we need higher number of substituents. Okay, so let's move to the next rule. Okay, what the cut it. So what's the third rule suggests? When the number of substituents are the same, then the substituent at the nearest position either end is prefer, or on the either end is prefer for the parent chain selection. Okay, so this one is the main I was talking about, the locants one. I mean, not the main, but the locants one. Locants means location. We need the lowest number of location on which the substituent is present. For example, if we see from here, if we count from here, this is our main chain. If we count from here, one, two, three, four, the locant, the substituent is present on fourth. The locant is fourth. But if we count from here, one, two, then the locant is two, which means if in this table, in this compound, a molecule will count from here because it will give us the lowest set of locant. Similar in this, see, this is carbon, this is first carbon, this is second carbon, this is third carbon, this is another carbon, this is another carbon, this is another carbon. Every joint has a carbon, okay? This is the line form of it. So if we count 1, 2, 3, 4, 5, 6, 7, 8. In this form it's 8. If we count from here, 1, 2, 3, 4, 5, 6, 7, 8. In this form it's also 8. 1, 2, 3, 4, 5, 6, 7. So that's why we're not taking the straight chain. Okay, but see, if we when we are counting from here, the lowest the substituent is present on the locant 2, but when we are counting from here, locant is present on 3. I mean the substituent is present on 3. So as the rule suggests, we will choose the lowest set of locant. So the main chain will come from here. See, chain A, chain B. So we are gonna choose chain B, the one with hyphen. Okay. Moving further, you can read this. I will provide the PDF. Don't worry. Here are two choices for longest chain. 1, 2, 3, 4, 5, 6, 7, 8, 9, and same goes backwards. So when the substituents are present on the same position when read from either side of the chain, then we use the last option, which was alphabetical order. Which comes first in alphabetical order will be used. For example, this is only one carbon. This is carbon attached. H, H, H. See, the carbon is attached. It is attached to a reaction. So this only has three hydrogen. So it means it's methyl. It's not methane. Remember, it's not methane. It's not methane because it doesn't have a H. It's attached to another chain here. It only has three, and three means methyl. Remember, when one H is subtracted, it becomes methyl. Comes in the group of alkyl groups, and from here it's C C H H. It's ethyl. Okay, here it's ethyl. So even though this one is bigger, but when we see from the word alphabetical order, ethyl comes first. So we're gonna use the chain in which ethyl will come first. 1, 2, 3, 4, 5, 6, 7, 8, 9. So in this case, the A chain. Both A chain and B chain, the substituents are at same position 4th. In chain A, substituent is ethyl, and in chain B, it is methyl. Alphabetically, ethyl is preferred, so we'll choose chain A. See? Okay, see, it's that easy. Okay. Now there are few hard rules which we're gonna see and understand in few minutes. Numbering of the parent carbon chain. Numbering of the parent carbon chain. Write the substituent in place of secondary prefix with their appropriate location in alphabetical order. So we have to write the location, means the locant on which the substituent is present, and the substituent is placed on the secondary prefix. The primary prefix, which is not yet known. Secondary prefix, word root. Okay, so we are gonna use it on the secondary prefix here. If the same substituent occurs more than once in the molecule, the prefix uh, di for 2, tri for 3, etc. used to indicate how many times it has appeared. So basically there can be more than one substituent, you know that. So we're gonna use, if there are similar substituent present more than one, then we're gonna use like this. If it's present on 2 and 3 both, then we will write the substituent name 2 and 3 like this. Okay, and the word. Prefixes di, tri, or tetra, etc. are not considered in deciding the alphabetical order for methyl, For example, for simple substituent, but considered for complex substituents. Okay, this might be a bit confusing, but let me explain you in a second. So, like we see here, wait, let me erase it all. For example, here is ethyl. Okay, imagine if there were two ethyl over the same position, then it would be counted diethyl. No, 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 sorry, sorry, sorry. Imagine if there were two methyl, then it would be called dimethyl. So considering that ethyl and dimethyl, the D is coming first. But but we not count this di, tri, tetra. We're not tetra. We're not gonna count this. We're only gonna count the main methyl name, main substituent name. Yeah, for now remember it. We're not gonna count this di, tri, or tetra. We're only gonna count the main name. If when choosing from the alphabetical order, we're only gonna focus on the main name of the substituent. Okay, so moving down, what are the other rules? Let's see. So ISO or NEO is considered for alphabetical seniority order. Yeah, the ISO and NEO group I told you before. This one is NEO group, I guess, and ISO was something like this. These two groups are considered for alphabetical order. Means if there it would be isoethyl, then you're gonna consider it. Okay, then you gonna consider the numbers are separated from words from each others by commas. So if it would be like two at same place, then we're gonna write four, like two, not two at same place, but like same substituents at two different locates. Then we're gonna write like this. It means it's present on fourth locant and sixth locant. And what's the substituent? For example, it's ethyl. I don't know, the name sounds sexy. That's why I use ethyl. Okay. Numbers are separated from words by hyphens, and there is no break between the name or name of substituent and word root. So we're gonna use these hyphens, these things. We're not gonna like leave a blank space. Blank space is not the appropriate way. More like it's the rule. You cannot use a like empty way. So empty space. So like for here, let's do this one. First, let's count the highest number according to the rule. We will count the highest number of carbon chain. Then we will see most number of substituent. Then we will see alphabetical order. Okay. I mean, look, we also forgot the locant one rule. Sorry, my bad. So if we choose from here, 1, 2, 3, 4, 5, 6, 7, 7, 1, 2, 3, 4, 5, 6, 7, 7, 1, 2, 3. Okay, 1, 2, 3, 4, 5, 6. 7 is the highest chain. Now we're gonna see the most number of substituent, which would be from here, from this chain. We get a methyl, we get a ethyl, and we get a propyl. Ethyl, methyl, propyl. So now we got these three. Ethyl, methyl is present on the second. Ethyl is present on the 1, 2, 3, third, and propyl is present on the fourth. But I mean, we're gonna choose from here, of course. Now the second rule, lowest set of locants. From here, the lowest second set of locant is on the fourth position, while on here it's from the second. So we're gonna choose from here. Okay. See, we're not focused, we're not applying, we're not using the alphabetical order yet. We're first see on which position the substituent is nearest to the end. And for now, from it's from the top. So we're gonna go like 1, 2. So now we're gonna apply the what we say alphabetical order. So in the alphabetical order, ethyl will of course come first. 3 ethyl. Then we're gonna do methyl, 2-methyl. See, this whole is a substituent, okay? This whole is called secondary prefix for now. And then we'll go 4-propyl. Then comes the word root. What is the word root? 7, apt. And since it's a alkane, apt, 8. See, easy. That's easy. That easy, dude. It's that easy. Okay, moving down. Okay, okay, let's do one more example. What is this? Oh my god, there's slide boundary. This should provided more space. But anyways, they're almost colliding. Let's count. 1, 2, 3, 4, 5, 6, 7. Or 1, 2, 3, 4, 5, 6, 7. I guess 7 is the highest number. So it would be happed. Consider that. Now we'll see from which position we're gonna yeah, from which position you're gonna getting the highest number of substituents, which is from here according to me. This is one, this is another. Wait a minute, you might, what the fuck, yeah. You might be, see, there is no bond, there is no this line there, from bonding. That means they are separate substituents. So 1, 2, 3, 4. From this one we are getting 4 substituent. I mean, from this one too we are getting 4 substituent, you can kind of say. But you can consider either of them. I mean, the word root won't change. Like it would be exactly same. Even if you count from here, the substituent would be at 2. Even if you count from here, the substituent would be at 2. So lowest set of locant is also decided. The lowest set of locant would be 2, means from the top. So what is now? So see, this is 2 methyls. This is a ethyl, and this is a propyl. So it would be go like 3 ethyl, H dash, 3 ethyl, 2 3. See, separated by commas if they are present on this. If two if two substituents are present on the same carbon chain, I mean, of course, on the same carbon chain, but on different numbers, then we're going to use comma. Even if they are present on the same number, if, for example, if there would be another methyl here, another methyl here, for example, then too we are going to write 2 2. Yeah, we're going to write like this: 2 2 dimethyl. Di means because there are 2 methyls. If there would be 3, then we'll put another comma and write 3. But for now, it's gonna be 2 3 dimethyl, and all the same. Wait, let me check if even if it's recording or not. Thank God it's recording. So what are the other ones? 1 2 3 4 5 6. I mean, this is easily, I mean, you can see it easily that this one is gonna be the longest chain. So 1 2 3 4 5 6. Which one is present than here on the second one? They've provided much information over here. Okay, so lowest set of locant is 2. As that means we are gonna start the table from here, the compound from here. Okay, 1 2. So now gonna methyl. There are 2 methyls and 1 ethyl. Ethyl comes first, so 3 ethyl in the alphabetical order. 2 4 2 4 dimethyl, and since it's hex, and hex, see, okay, see, easy. That's easy. Yeah, basically you're done with half of it. I mean, that's the most part which is gonna be coming in your exam. Okay, so let's move. IUPSC. Okay, wait a minute. Yeah, wait a second. IUPSC nomenclature of alkene, cycloalkene, polyalkenes, and alkynes. Oh, so in the rule I told you earlier, there's gonna be just a slight change. Okay, as I said, with respect to the bond. We're gonna count the number of carbon with respect to the bond. So here, let's see what it says. Functional group. We're gonna ignore this for now. I mean, it's not a functional. It's a functional group, but same time it's just here. A functional group is something that gonna decide the chemical and physical properties of a compound. So considering this one guy got a higher power, you will understand that in GOC. But for now, okay, this is something. Select the longest carbon chain containing carbon-carbon double bond. This need to be the longest chain in the whole compound as a whole. Parent name will be alkene, corresponding to the number of carbon atoms in the longest chain. Oh my god, okay. So basically it says that no matter what the fuck table looks like, if the carbon at if the a double bond is present here, then you're gonna start from here. Then you have to start. Then have to start from here. No matter if this one is like 18 carbons long, no worries. I mean, you can go either ways. If it's too long, you can go this side, but you have to fucking start from here. Okay, that's it. You gotta start from the double bond. You gotta include the double bond in the main chain. That's what they are asking. Okay, so this 6. They've not that did the perfect name. See, and we have to try, if the bond is not on the, like, it's not given here, but if the bond is not on the on either end, but if, for example, if the bond was here, not here, then too we will do, either will go from here or here. We have to give it the lowest set, lowest number. Okay, same thing like with the substituent. Okay, so longest chain has 6 atoms. Parent name hexane, hex because it's 6, 1 2 3, and ane. What? Wait, what? Wait, what? I guess they haven't named it here. Okay, don't get confused. They're gonna be naming it later. Carbon atom in the long carbon atom in the longest carbon atom in the longest chain is numbered from that end in such a way that the double bonded carbon atom gets the lowest. The position of double bond is indicated by the smaller number assigned to the to two carbons out of the position of double bond is indicated by smaller number assigned to two carbon atoms of double bond. So basically they are telling you that you have to assign lowest number to the bond. I mean the bond, to the carbon which are present in the bond, the double bond, double or triple. So for now it's like here. Yeah, but so see, we got two substituent. So first it would be 1 2 3 4 5 6. 6 means hex. Okay, since it's 3 means, I mean we counted the like most number of substituent we can get from this parent chain because the bond is present here. There are two, and there is methyl and propyl. So methyl comes first. So 3 methyl, 3 propyl, propyl, hex, then 1 E. You actually you don't have to include 1 if it's present in 1. Only the I'm talking about alkane, like this, what do we call it? Primary suffix. If the primary suffix value is 1, you have to include it in substituent. But if the primary suffix, this is a primary suffix, alkane, ane, ene, diene, and ine, and all this, you have to, if there is 1 here, you can just write it hexene. But still, I mean, if you want to impress the teacher, then you should write 1 e. Okay. Okay, there are a few more example, I guess. See, so see in this one, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, so in this one, the double bond is present in the between, like in the middle of it, and it's almost similar on both the ends. So no matter from where it, even if you count it from here, it would be same. So for example, let's take this as our parent chain, and let's count it from here. 1, 2, 3, 4, 5, 6. Then when we see the lowest set of locates, it would be at 2, and from here it would be at 2, 2, and then it's from 5. So we're gonna write 2, 2, because they all are methyl. 2, 2, 5, 5. Tetra means 4. Methyl, hex. Now see, now it's not present at 1, so we have to tell them that it's not present at 1. Hex, so 1, 2, 3. So hex 3 E. Okay, alkynes. Parent chain and selection and numbering of longest chain is exactly same for as that for alkynes. There is a slight twist, but other than that, it's almost the same. Parent chain selection and numbering for longest chain. See, they haven't drawn it perfectly. It's gonna be a slight as a bond here. Okay, 1, 2, 3, 4. 4 carbons. Bute, since it's present in 2. Bute 2 ine. Remember the, you know, the, what do we say, suffix, primary suffix of alkyne, that's ine. Since there are no substituent present here, we don't have to write anything. But in this one, there are substituent, there are many things. So first of all, we are gonna count from where it gets the lowest location, lowest number, which will be from here. We're gonna take this as the main chain. 1, 2, 3, 4, 5. Now we get 2 methyl, and that are at 4, 4, 4. Die, because there are 2 methyl pent, because the carbon chain have 4 main carbon atom. 1, 2, 3, 4, 5. I mean 5 main, sorry, and it's presented first. So pent 1 ine. Okay. Now here comes the crucial part. You might think, if both alkyne and alkene are present in the same chain, then alkyne will get the highest, you know, order. But no, alkyne won't. Alkyne isn't necessary. Alkene is the one which will be prioritized. Numbering is done in a manner that double bond and triple bond gets the lowest number possible. If double bond and triple bond both have same number, then double bond is preferred over triple bond. See, for example, if at here it's double bond and here it's triple bond. For example, this is one from here, this is one from here. Then we will choose the double bond. But for example, if double bond is present here and triple bond is present here, then we are gonna choose triple bond because we need the lowest number. But if we have the lowest number, then uh, we will see what kind of bond it is. Double bond, I mean single pi bond is greater than mm, double pi bond. I might get confused by using the different name. I mean, I use single, and the book it's written double and triple, so you can say double, I guess. That would be more easier for you. Triple over here. So double pi bond is prioritized over the triple one. Okay. So for example, in this one, see, we get triple bond at 1, 2 and double bond at 1, 2. But we're gonna prioritize the double bond, and we'll count from here. 1, 2, 3, 4, 5. 5 means spent, and since it got no substituent, but it got two, uh, what we say, you can write it like pent 1 in and 1, 2, 3, 4. 4 ine. This is gonna what it look like. Okay. Yeah. So moving further. So this one is a quite hard one. You might not understand how many carbons are there, but let me tell you. First carbon is here. This is a double bond. Second carbon is here. Third carbon is here. Fourth carbon is here. Here it's a triple bond. See, two pi bonds. Fifth it's here. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. And the wait, what? 1, 2, 3, 4, 5, 6, 7, 8. Yeah, 8. My bad. I don't know how did I suck at counting over there, but okay. So it got no substituent, means the chain would be simple, no lower set of look and another rule. But we'll see the double bond is present here, so we'll run from here for oct 1 in. See, double bond is always written first, okay? I mean, the one with the lowest number will be written first, okay? I mean, no, no, sorry, my bad. Then, sorry, forget it. I meant the one which would have the lowest number won't matter. In double bond will always double bond gets priority, so double bond will always be written first. So 1 in 4 in. So 1, 1, 2, 3, 4. And when we go on about second model, the second molecule 1, 2, 3, 4, 5, 6, 7. 7 means hept. Now remember, when it's diene, like, oh my bad. I forgot a crucial role. I told you that when there are something like two, then vowel would be removed. A, E, I, O, U. And when there are, like, if you go back to the previous lecture where I told you the primary suffix, there was in the last one there was, wait, let me show. Here, when it says when two with double, both double and triple bonds of, no, unsaturated with two double bonds would be A plus diene, and the both double and triple bonds in iron. See, that's what I missed. My bad. Sorry, guys. My bad. Hmm. I messed a bit. Yeah, so it was in iron. In whatever the number here it is, 1, 2, 3, whatever, and iron. And for here, hepta was A plus di. Whenever it's di or tri or tetra or whatever, there would be a added, okay? Hepta, di, hepta. So the, as I said, double bond would be written first. So 1, 1, 2, 3. It's presented at 3, comma 4, 5, 6. We are only gonna choose the starting. You might wondering why we are not counting this one, 4 and 6, but we are only gonna see the starting one. Okay, hepta 3, 6, hepta 3, 6, di in. Okay, so I guess that's it for this lecture, and in the next lecture we're gonna be learning about IUPAC nomenclature of acyclic compounds, also known as cyclocompounds, the one in which we are gonna be using the primary prefix. Wait, let me show you again. Primary prefix, this one, cyclo one. Okay, so I guess you would like this lecture. Take care.